triplet. If A, B, C are three numbers where C greater than A and C greater than B such that A square plus B square is equal to C square, then ABC is called Pythagorean triplet. For example, 3, 4, 5, 6, 8, 10 and 5, 12, 13 are Pythagorean triplets because 3 square plus 4 square is equal to 5 square. 6 square plus 8 square is equal to 10 square. 5 square plus 12 square is equal to 13 square. Thus, for any number m greater than 1, 2m, m square minus 1 and m square plus 1 is a Pythagorean triplet. Example: write a Pythagorean triplet whose one number is 14. Solution: we know that 2m, m square minus 1, m square plus 1 is a Pythagorean triplet. Let 2m equal 14. This implies m is equal to 7. Therefore, m square minus 1 is equal to 7 square minus 1, which is equal to 48, and m square plus 1 is equal to 7 square plus 1, which is equal to 50. Hence, 14, 48, 50 is a Pythagorean triplet. Square roots. We know that 4 is the perfect square of 2 as 4 is equal to 2 square. 9 is the perfect square of 3 as 9 is equal to 3 square. 16 is the perfect square of 4 as 16 is equal to 4 square. 25 is the perfect square of 5 as 25 is equal to 5 square. Now, consider its reverse. We say that 2 is the square root of 4. 3 is the square root of 9. 4 is the square root of 16. 5 is the square root of 25. The square root of a number x is that number which, when multiplied by itself, gives x as the product. We denote the square root of a number x by, for example, square root of 25 is represented as equals 5. Square root of 64 is represented as is equal to 8, and so on. To find the square root of a given number, we have to find a number which, when multiplied by itself, gives the given number. For example, the square root of 25 is equal to 5, as 5 into 5 is equal to 5 square, which is equal to 25. Though minus 5 into minus 5 also gives 25, but we will consider only positive numbers. Properties of square roots. The square root of an even square number is an even number, and square root of an odd square number is an odd number. Square root of even square numbers. Square root of 4 is equal to 2. Square root of 16 is equal to 4. Square root of 36 is equal to 6. Square root of 64 is equal to 8. Square root of odd square numbers. Square root of 9 is equal to 3. Square root of 25 is equal to 5. Square root of 49 is equal to 7. Square root of 81 is equal to 9. If the units digit of a number is 2, 3, 7 or 8, then it does not have a square root in the set of natural numbers. If a number has a natural number as square root, then its units digit must be 0, 1, 4, 5, 6 or 9. Negative numbers have no square root in the system of natural numbers. For example, square root of minus 25 not equal to 5. Square root of minus 36 not equal to 6. Square root of negative numbers are imaginary numbers, and we will study such cases in higher classes. We shall now discuss the following methods to determine the square roots. Prime factorization method, successive repeated subtraction method, long division method. To find square root by prime factorization method, by definition, square root of 9 is equal to square root of 3 into 3, which is equal to 3. Square root of 16 is equal to square root of 4 into 4, which is equal to 4. Square root of 25 is equal to square root of 5 into 5, which is equal to 5. Consider the above three square roots. We can find the square root of a perfect square by using the following steps. Step 1. Write the prime factors of the given number. Step 2. The number being the perfect square will have one or more pairs of the same prime factors. Pick up and write one factor from each pair. Step 3. Multiply the factors selected. The product will be the square root of the number. Example: find the square root of 625. Solution: 625 is equal to 625 divided by 5, 125 divided by 5, 25 divided by 5, 5 divided by 5, 1. 5 into 5 into 5 into 5. Therefore, square root of 625 is equal to 5 into 5 into 5 into 5, which is equal to 5 into 5, which is equal to 25. Example: find the square root of the following numbers by prime factorization method. 47089. Solution: 47089 is equal to 47089 divided by 7, 6727 divided by 7, 961 divided by 31, 31 divided by 31, 1. 7 into 7 into 31 into 31. Therefore, square root of 47089 is equal to 7 into 7 into 31 into 31, which is equal to 7 into 31, which is equal to 217. To find square root by successive subtraction method, we know that sum of the first n odd natural numbers is n square. That is, 1 plus 3 plus 5 plus 7 plus 9 plus 2n minus 1 is equal to n square. With the help of this, we can find the square root of smaller natural numbers. This method is time-consuming for finding square root of large natural numbers. Step 1. From the given number whose square root is to be determined, subtract successively odd numbers 1, 3, 5, 7, 9, and so on. Step 2. Keep on performing subtraction till we arrive at 0. Step 3. The number of times we have to perform subtraction will be the square root of the given number. Example: find the square root of 49 by repeated subtraction. Solution: we have 49 minus 1 is equal to 48. 48 minus 3 is equal to 45. 45 minus 5 is equal to 40. 40 minus 7 is equal to 33. 33 minus 9 is equal to 24. 24 minus 11 is equal to 13. 13 minus 13 is equal to 0. We have performed subtraction 7 times. Hence, square root of 49 is equal to 7. Examples: what would be the possible ones digit of the square root of the following numbers? Also, state whether the square root will be an even or an odd number. 5329. Solution: since ones digit of 5329 is 9, the possible ones digit of the square root may be 3 or 7. It will be an odd number. Word problems on squares and square roots. Example: the product of two numbers is 972 and their quotient is 4 upon 3. Find the numbers. Solution: let one number be a, then the other number is 972 upon a. Given that a upon 972 upon a is equal to 4 upon 3. This implies a square upon 972 is equal to 4 upon 3. This implies a square is equal to 972 into 4 upon 3, which is equal to 324 into 4. This implies a is equal to square root of 1296. 1296 divided by 2 is equal to 648 divided by 2, 324 divided by 2, 162 divided by 2, 81 divided by 3, 27 divided by 3, 9 divided by 3, 3 divided by 3, 1, which is equal to 2 into 2 into 2 into 2 into 3 into 3 into 3 into 3. This implies A is equal to 2 into 2 into 3 into 3. A is equal to 36. Therefore, one number is 36 and the other number is 972 upon 36, which is equal to 27. Hence, the numbers are 36 and 27. Example, the product of two numbers is 10625. If one number is 17 times the other number, find the numbers. Solution. Let one number be x. Other number will be 17x. Then, x into 17x is equal to 10625. This implies 17x square is equal to 10625. This implies x square is equal to 10625 upon 17, which is equal to 625. This implies x is equal to square root of 625. 625 divided by 5, 125 divided by 5, 25 divided by 5, 5 divided by 5, 1, which is equal to square root of 5 into 5 into 5 into 5, which is equal to 5 into 5, which is equal to 25. Therefore, one number is 25 and the other number is 25 into 17, which is equal to 425. So, the numbers are 25 and 425. To find square root by division method. When the numbers are large, even the method of finding square roots by prime factorization method become lengthy and difficult. By method of division, square roots can be easily determined. Step 1. Place a bar over every pair of digits, starting from the digit at units place. If the number of digits in the given number are odd, then the single digit which is left will also be under the bar. Step 2. Find the largest number whose square is less than or equal to the number at the extreme left under the bar. Let this number be the divisor and the quotient. So, 2 here is the divisor as well as the quotient. Step 3. Subtract the product of the divisor and the quotient from the number at the extreme under the bar to get the remainder 2 in this case. Step 4. Copy the other pair under the bar to the right of the remainder. This becomes the new dividend. In this case, it is 276. Step 5. Double the divisor. 2 into 2 is equal to 4 and write it with a blank on the right. Step 6. Guess the largest possible digit. To fill the blank, step 5 in such a way that the product of new divisor and the new quotient is equal to or just less than the new dividend. Step 7. Subtract. To get the remainder, see that the remainder is 0 and no digit pair of given number under the bar is left. Therefore, square root of 676 is equal to 26. Example, find the square root of the following by division method. 4489. Solution, 4489. Square root of 4489 is equal to 67. Word problems. Find the least number which must be added to 1500 so as to get a perfect square number. Also, find the square root of the perfect square number. Solution. Let us try to find the square root of 1500 by division method. It implies 38 square less than 1500. Now, the next number is 39. 39 square is equal to 39 into 39, which is equal to 1521. Also, 39 square minus 1500 is equal to 1521 minus 1500, which is equal to 21. Hence, the number to be added is 21. Square number is equal to 1500 plus 21 is equal to 1521. Now we find the square root of 1521. The square root of 1521 is 39. To find the number of digits in the square root without calculating the square root. If we observe the square roots of numbers calculated by division method, the bar placed over the pair of numbers indicates the number of digits the square root of the numbers will have. Square root number, number of bars, solution, square root of number, number of digits in the square root, 64, 1, 8, 1, 4, 41, 2, 21, 2, 12, 96, 2, 36, 2, 2, 56, 00, 3, 160, 3. The number of bars is the number of digits in the square root of the given number. Example, without calculating the square root, find the number of digits in the square root of the following numbers. 36864. Solution. Square root of 36864 is equal to 36864. Square root will have 3 digits. To find the square root of rational numbers, fractions. If a and b are two natural numbers, then square root of a upon b is equal to square root of a upon square root of b. If the given fraction is a mixed fraction, it is converted into an improper fraction. To find the square root of the rational number a upon b, we find the square root of the numerator and the square root of the denominator separately. Example, find the square root of 9 and 67 upon 121. Solution, let a upon b is equal to 9 and 67 upon 121, which is equal to 1156 upon 121. Square root of a upon b is equal to square root of 1156 upon 121, which is equal to square root of 1156 upon square root of 121. Square root of a is equal to square root of 1156, which is equal to 34. Square root of b is equal to square root of 121 is equal to 11. Hence, square root of 1156 upon 121 is equal to 34 upon 11, which is equal to 3 and 1 upon 11. Square root of decimals. Observe the following examples. 0.2 into 0.2 is equal to 0.04. Therefore, square root of 0.04 is equal to 0.2. 0.51 into 0.51 is equal to 0.2601. Therefore, square root of 0.2601 is equal to 0.51. 0.322 into 0.322 is equal to 0.103684. Therefore, square root of 0.103684 is equal to 0.322. It is clear from the above examples that square of a decimal fraction has twice the number of decimal places in the given number. The number of decimal places in the square root of a given decimal fraction is half the number of decimal places in the given number. To find the square roots of rational numbers which are in decimal form, the following steps should be followed. Step 1. Put bars on the integral parts. Step 2. In the decimal part, place the bar making pairs of digits starting from the first decimal place. Affix a 0 on the extreme right of the decimal part to make it even, if necessary. Step 3. Find the square root by division method as done earlier and put the decimal point in the square root before bringing down the pair from decimal part of the number. Example, find the square root of the following. 4.6225. Solution. 4.6225. Hence, square root of 4.6225 is equal to 2.15. To find approximate value of square root, the square root of the numbers which are not perfect squares can be obtained by division method up to a certain decimal place. This can be done by adding suitable number of zeros in pairs at the extreme right of the decimal part of the number. Example 4. Find the square root of 5 correct to 3 places of decimal. Solution. Therefore, square root of 5 is equal to 2.236.
Find the square roots of 2 correct to 3 decimal places. Solution. The number 2 is not perfect square. Since we require the square root of 2 correct to 3 places of decimals, we will find the square root up to 4 places. For this, we have to add 4 pairs of zeros after decimal point. We will then approximate the value to 3 places of decimal. Therefore, under root 2 is equal to 1.4142. Since the digit at 4th place is 2, which is less than 5, we can omit it. Hence, under root 2 is equal to 1.414.
Example 7. If square root of 2 is equal to 1.4142, find the value of square root of 8, correct to 3 places of decimal. Solution. Square root of 8 is equal to square root of 2 into 2 into 2, which is equal to 2 into square root of 2, which is equal to 2 into 1.4142, which is equal to 2.8284. Since square root of 2 is equal to 1.4142, therefore, square root of 8 is equal to 2.828, correct to 3 places of decimal. Using square root tables, we have learnt to find out the square root by factorization method and long division method. These methods sometimes become time-consuming and cumbersome. From the square root tables, we can find out the approximate value of the square roots of numbers, correct to 3 decimal places. Example 1. By using the table for square roots, find the value of square root of 27 upon 25. Solution. Square root of 27.25 is equal to 1 upon 5 square root of 27. Look at the table. The entry in the column of square root of 27 is 5.196. Therefore, square root of 27.25 is equal to 1 upon 5 square root of 27, which is equal to 1 upon 5, 5.196, which is equal to 1.0392. Example 2. Using square root table, find the value of square root of 1.62. Solution. Square root of 1.62 is equal to square root of 162 upon 100, which is equal to square root of 81 into 2 upon 100, which is equal to 9 upon 10 square root of 2. From the square root table, square root of 2 is equal to 1.414. Therefore, square root of 1.62 is equal to 9 upon 10 square root of 2, which is equal to 9 upon 10 into 1.414, which is equal to 12.726 upon 10, which is equal to 1.2726. Example 3. Using square root table, evaluate square root of 23.47. Solution. For square root of 23.47, we find approximate difference between square root of 24 and square root of 23. Square root of 24 is equal to 4.899. Square root of 23 is equal to 4.796 from the table. Square root of 24 minus square root of 23 is equal to 4.899 minus 4.796, which is equal to 0.103. For the difference of 1, which is equal to 24 minus 23, the difference between square root of 24 and square root of 23 is equal to 0.103. For the difference 0.47 is equal to 0.103 into 0.47, which is equal to 0.04841. Therefore, square root of 23.47 is equal to 4.796 plus 0.04841, which is equal to 4.844 approximate.